Hello everyone, welcome back to Physics Online CT classes for class 11 and 12 standard students. Again we are going to continue the chapter Units and Measurement. Already we have completed 2 sessions on the same chapter. Nearly we completed 58 multiple choice questions. Again today I am going to continue the remaining multiple choice questions. So let us start the class. Dimensions of a physical quantity. The question number 59. So from 59th question, it is related to dimensions of a physical quantity. Yes, let us start with 59th question. Better you can use the given CET material so that it will be very easy to understand the multiple choice question. Yes, 59th question. The dimensional formula of pressure is. Yes, we know that pressure is given by the equation force per unit area. Yes, what is the dimensional formula for force? We know that M-L T raised to minus 2 divided by area. Area is what? Length into breadth. So that gives L square. So now we can write the dimensional formula for pressure will be how much? 1 L will get cancelled. M L raised to minus 1 T raised to minus 2. This is the dimensional formula for pressure. Now you can choose the right option. M L raised to minus 1 T raised to minus 2. So option C is right. Question number 60. The dimensional formula for impulse is. First you have to know what is impulse. Yes, impulse is large amount of force acting in a short interval of time. Force into time is called impulse. And we know the dimensional formula for force. What is that? M, L, T raised to minus 2 and time is T. So the dimensional formula for impulse will be what? M, L, T raised to minus 2 plus 1 will be what? Minus 1. M, L, T raised to minus 1. This is the dimensional formula for impulse. So option C is right. 61st question. The dimensions of a potential energy is. What is potential energy? The energy possessed due to its position. Yes, potential energy is given by the equation mgh. M is mass. G indicates acceleration due to gravity. Acceleration dimensional formula is L T raised to minus 2. H is height. Height is equivalent to length. So the dimensional formula for potential energy will be what? M L square T raised to minus 2. This is the dimensional formula for potential energy. M L square T raised to minus 2. That means option B is right. Question number 62. The dimensional formula for relative density. Yes, first you have to know what is relative density. Generally density is what? Mass per unit volume, right? So relative density is, we are just comparing density of one substance with standard density or density of another substance. Anyhow, density is denoted by the symbol rho. A rho divided by rho will get cancelled. So it will be dimensionless. Dimensionless, or you can write M raised to 0, L raised to 0, T raised to 0. So the relative density is not having any dimension. Option D is right. 63rd question. The dimensional formula for angular momentum. Yes, first you have to know what is angular momentum. We know that linear momentum is product of mass and velocity. Similarly, angular momentum is the product of moment of inertia and angular velocity. L equal to I omega. I indicates moment of inertia. Omega indicates angular velocity. Yes, first year students, you are going to study about angular momentum, moment of inertia and angular velocity in the chapter System of Particles and Rigid Body. But for the 12th standard students, you have studied in your first year, so it is easy for you to write the dimensional formula. L equal to I omega. I is given by the equation m r square. I equal to m r square. And omega equal to what? We know that V equal to R omega. Omega equal to V divided by R. So in place of omega, I can write V divided by R. Now you can write the dimensions. M, R means what? Radius, radius of gyration or radius. It is equivalent to length L square, M L square. V indicates velocity, velocity dimension is L t raised to minus 1 divided by R indicates radius is equal to length. So L equal to, here we can write M, here L will get cancelled, L square t raised to minus 1. M L square t raised to minus 1. This is the dimensional formula for angular momentum. Now you can observe which is the right option. Option B. Question number 64. The dimensional formula for a torque. About torque, first year students, you are going to study in the chapter System of Particles and Rigid Body. Torque is denoted by the symbol tau. Tau equal to R cross F. R indicates position vector or radius. F indicates force. Yes, this is what L into F is force. Force dimensional formula is mL t raised to minus 2. So the dimensional formula for torque will be mL square t raised to minus 2. This is the dimensional formula for torque and the right option is A. Question number 65. The dimensions of a gravitational constant G. You have studied in the theory classes about the dimensions of the gravitational constant, or you can remember the equation. Gravitational constant is given by Fr square divided by m1 m2. Easily now you can substitute their dimensions. Force is mL t raised to minus 2. Radius is equal to length, so we can write L square divided by mass m and m. Or we can write G equal to, here 1 m will get cancelled. This m we can take to numerator, it becomes m raised to minus 1. L into L square will be L cube. Remaining is t raised to minus 2. So this is the dimensions of gravitational constant G. So the right answer is option C. Which of the following is a dimensional constant? Yes, you can observe all the four options. Which is dimensional constant? See here the first option, that is refractive index. Refractive index means speed of light in one medium. Speed of light in one medium to the speed of light in other medium. Generally we can write the equation as n2 divided by n1. You have studied about refractive index in ray optics, and for first year students you have studied in your high school days about light chapter. You can remember refractive index. So n2 by n1, speed of light divided by speed of light. So it will get cancelled. So we will get answer in terms of number. Number means it is a dimensionless. It is not having any dimensions. Then second option you can observe Poisson's ratio. Yes, Poisson's ratio means it is a change in strain to the original strain. Change in strain to the original strain, that gives Poisson's ratio. Change in strain to the original strain, strain and strain, again it will get cancelled. So this is also dimensionless. Then come to the option C. C is what? A strain. Yes, what is a strain? Change in dimension to the original dimension. That means a change in length to the original length, change in area to the original area, change in volume to the original volume. Anyhow, change in dimension to the original dimension will get cancelled. Again, it is also dimensionless. These are not having any dimensions. Come to the last option, it should be right, or you can see here gravitational constant. So G is gravitational constant. Just we know the dimensional formula for gravitational constant. What is that? We got G equal to m raised to minus 1, L raised to 3, T raised to minus 2. And it is also having the value 6.67 into 10 raised to minus 11 Newton meter square per kg. This is dimensional constant. That means its numerical value is also constant and also it is having dimension. So which is the right option? Option D is right. Question number 67. In the equation momentum is denoted by P. P equal to, here one equation is given, mass divided by area into x. The dimensional formula of x is L T raised to minus 2. Right? Then another statement is given, quantities with different dimensions can be multiplied. The physical quantities with different dimensions can be multiplied. There are two statements here. Now, which is the right statement you have to observe? First, you can observe the statement 1. The given equation is P equal to mass divided by area into x. This is the given equation. Or we can write x equal to, it can be written as P into area divided by mass. Now easily you can substitute the dimension. P indicates momentum. Momentum means mass into velocity into area divided by mass. So here we can write m into v. V means velocity. Velocity dimension is lt raised to minus 1 into area is L square divided by m. So here m will get cancelled. We will get L cube T raised to minus 1. This is the dimension of x. Now again read the statement 1. In the equation of momentum P equal to m mass by area into x, the dimensional formula of x is, they had given L T raised to minus 2, but what we got? We got L raised to 3 T raised to minus 1. So statement 1 is wrong. Come to the second statement. Quantities with different dimensions can be multiplied. Yes, you can observe here. This part you can observe. Mass, velocity, area. These are having different dimensions and we are multiplying. M is the dimension of mass. V, velocity, is having dimension L T raised to minus 1. Area is having dimension L square. All these quantities are having different dimension but also we are multiplying. That indicates second statement is correct. Yes, observe the options here. The first option, both statement 1 and 2 are true. Statement 2 is the correct explanation for statement 1. No, this is wrong. Both statement 1 and statement 2 are true, but statement 2 is not correct explanation for statement 1. This is also wrong because statement 1 is wrong, statement 2 is true. And come to the option C. Statement 1 is true, but statement 2 is false. No. Come to the last option. Both statement 1 and statement 2 are false. See here, there is a mistake here in the given option. Let us consider statement 2 is true, statement 1 is false. Just you can make the corrections in the given material. So statement 2 is true, statement 1 is false. Let us consider here option C is right. Is it clear? Come to the next question. Question number 68. The dimensions of Reynolds constant is. Yes, first you have to know what is Reynolds constant. Reynolds constant, it is just a number. It is a pure number. If it is a number, then it is having any dimension? No, it is not having any dimension. See here, Reynolds constant is a pure number, hence it has no dimensions. right? Yes, Reynolds number. So this constant number helps to predict the flow pattern in a different fluid flow situations. That number gives, or it can predict flow pattern in a different fluid flow situations. Or this Reynolds number is generally given by the equation. This is rho u L divided by mu. This is the equation for Reynolds constant. So here rho indicates density of the fluid, U indicates this is the flow speed, and L indicates this is linear dimension, or you can take a length, linear dimension, and mu indicates dynamic viscosity, because this number is related to mechanical properties of fluid. Is it clear? Anyhow, Reynolds constant is a pure number, so that it is not having any dimension. So if it is not having any dimension, we can write m raised to 0, L raised to 0, T raised to 0. So that option A is right. Come to the next question. Question number 69. Which of the following will have the dimensions of time? Yes. Which of the following option is having the dimension of time? About electric current, current electricity, charge, field. So all these terms you are going to study in second PUC. But for the second year students, you can easily understand this question. But R, L, C, these terms you will come to know in the chapter electromagnetic induction in detail. Just observe the solution here. We know that Ohm's law V equal to IR, right? And related to inductor, we have one more equation, V equal to L into di divided by dt. Already studied Ohm's law in the chapter current electricity. You can easily understand this equation. Second equation is V equal to L into di by dt. So here L indicates inductance, coefficient of inductor, or self-inductance or mutual inductance. L indicates coefficient of inductance. So I am going to use these two equations here, because in the given options, you can observe all the four options. Option A, inductor into capacitor. Option B, resistor divided by inductor. Option C, inductor divided by resistor. Option D, capacitor divided by inductor. In all the four options, there is the term L, and L indicates inductance. Right now, so I am going to use the equation 2 here. So I can write from equation 1 and 2. From equation 1 and 2, I can write IR equal to L di divided by dt. Right? So now I can write the dimensions. I, that indicates current, R indicates resistance, is equal to L is inductance, and di, let us write it as I, divided by time is T. Yes, here I will get cancelled. So we will get resistor R is equal to L divided by T. Right? L divided by T. But we want time dimension. Therefore, T equal to, we can take that R on RHS side, it will go to denominator. So we will get L divided by R. So dimension of time is equal to L divided by R. L divided by R means what? Option C is the right answer. Question number 70. LCR represents physical quantities, inductance, capacitance and resistance respectively. The combination which have the dimension of frequency are. Here three physical quantities are given. LCR. LCR indicates inductance, capacitance and resistance. The combination which have the dimensions of frequency. Yes, we know the frequency equation. This is F equal to 1 divided by root of LC. We are going to call it as resonant frequency. What it is? Resonant frequency. About this term, you are going to study in detail in the chapter alternating current. That is for the second PUC. F equal to 1 by root of L. So just now you can remember this equation. F equal to 1 divided by root of L into C. L indicates inductance, C indicates capacitance. Now you can easily substitute dimensions of inductance, dimensions of capacitance. You will get the answer. Right? See here I am going to substitute their value 1 divided by root of. We know that dimension of inductance is given by m L square t raised to minus 2 a raised to minus 2. Similarly, capacitance is having the dimension m raised to minus 1, L raised to minus 2, t raised to 4, a raised to 2. These are the dimensions of inductance as well as capacitance. So we will get the answer 1 divided by root of m and m raised to minus 1. So m raised to 1, m raised to minus 1 will be 0, leave it. L raised to 2, L raised to minus 2. So this will also 0, leave it. Then come to the third term t raised to minus 2, t raised to 4. So we can write minus 2 plus 4. Then a raised to minus 2, a raised to plus 2. So it will also cancel. So we will get 0. So here you can observe 1 divided by root of minus 2 plus 4 will be 2 t square. 1 by under root of t square is what? 1 by t. F equal to 1 divided by t. For which equation? 1 by root of LC. But now the question is, how to find the dimensions of L and C? Here I wrote directly the dimensions of inductance and capacitance. But you have to know how to write the dimensions of inductance and capacitance. Just I will explain the dimensions of inductance and capacitance. You can observe here. We have the equation in inductance E equal to half L I square. Here E indicates energy. Energy stored in an inductor is E equal to half L I square. So this equation again you are going to study in the chapter electromagnetic induction. Now you can just remember this equation to find the dimensions of inductance. Yes, this equation can be written as L equal to 2E divided by I square, or L equal to 2 is what a number? It is a dimensionless. Leave it. E indicates energy. Energy dimension we already studied. M L square t raised to minus 2 divided by current. Current is having the unit ampere. A indicates ampere. Ampere is also fundamental unit. So we can write A square. So then we can finally write the dimension M L square t raised to minus 2, a raised to minus 2. This is the dimension of inductance. Here I wrote, you can observe m L raised to 2, t raised to minus 2, a raised to minus 2. Similarly, how to write the dimension of capacitor? You can observe, we know that capacitor is given by the equation C equal to Q divided by V. About this equation you have studied in the chapter capacitance of a capacitor, chapter 2. Right? Here this equation can be written as C equal to Q is what? The amount of charge or the positive charge or a unit charge. So here in place of Q I am going to write I into T divided by V indicates potential difference or voltage. So why we have to write I into T in place of Q? Because we know that electric current is I equal to Q by T. Q equal to I into T. Yes, now we can substitute their values. You can observe C equal to I is having the dimension ampere and remaining is time T divided by potential difference. Yes, we know that potential difference means it is V equal to W divided by Q. C equal to ampere, capacities, time T, capacities divided by W means work dimension we already studied, M raised to 1, L raised to 2, T raised to minus 2 divided by, in place of Q again we can write I into T, that is A into T. So now we will get C equal to A square T square divided by M raised to 1 L raised to 2 T raised to minus 2, or we can write C equal to M raised to minus 1 L raised to minus 2. So T raised to 2, T raised to minus 2, when it goes to numerator it becomes T raised to 2 plus 2 will be T raised to 4. Remaining is ampere, that is A square. So this is the dimension of capacitance. You can observe we substituted the capacitance value here. You can observe dimension. M raised to minus 1, L raised to minus 2, T raised to 4, A raised to 2. This is the dimension of capacitance. So if you know the equations, using those equations, using derived quantities, easily you can write the dimensional formula for any physical quantities. So which is the right option here? Option C, that is F equal to 1 divided by root of LC. This is resonant frequency. Then 71th question. Two quantities A and B have different dimensions. Which mathematical operation given below is physically meaningful? There are two physical quantities given A and B, and these two are having different dimensions. Which mathematical operation given below is physically meaningful? Yes, see here, this is very easiest question. You have studied in the theory classes about the principle of homogeneity of dimensions. You can see here the principle of homogeneity of dimension. According to this principle, addition, subtraction or equality between two physical quantities, if they are having different dimensions, this is not possible. While you can take arithmetic operations like multiplications and division for two different physical quantities having different dimensions are possible. That means if the quantity is having different dimension, then you can multiply or you can divide. But you cannot add or subtract or equality. Right? So now you can observe the given options. A over B. Option B, A plus B. Option C, A minus B. Option D, A equal to B. Now tell me which is the right answer. A plus B, A minus B, A equal to B. So these operations are not possible when the quantities are having different dimensions. Then which is the right option? A over B. Either division or multiplication is possible according to the principle of homogeneity. So option A is right. Come to the question number 72. Which of the following is a dimensional constant? Yes, options are refractive index, dielectric constant, relative density, gravitational constant. So this question is repeated here. You can observe the question number 66. Right? So we know the answer directly. You can write gravitational constant. Question number 73. Of the following quantities, which one has the dimensions different from remaining three? Which is having dimensions different from remaining three. That means in the given four options, three options are having same dimension and the remaining one is having different dimension that we have to find here. Yes, the first option is given energy per unit volume. Yes, you can substitute the dimension. Energy is given by the equation M L square T raised to minus 2. This is the dimension of energy divided by volume is what? Length into breadth into height, that gives L cube. So we will get the dimension of energy per unit volume is M. L raised to 2 minus 3 will be L raised to minus 1 T raised to minus 2. So this is the dimension of first option. Come to the second option, force per unit area. Force per unit area means what? Pressure. Pressure dimensional formula. If you know the direct answer, you can write, or you can write the dimension of force M L T raised to minus 2 divided by area is L square. So we will get the answer M L raised to 1 minus 2 will be minus 1 t raised to minus 2. So this is also having same dimension. Come to the option C here. Option C is product of voltage and charge per unit volume. See here, C option, product of voltage, that is potential difference V, into charge per, charge means Q, per unit volume, this is volume. Don't get confused with, this is potential difference. V indicates potential difference here. Right, we can write potential difference V equal to, we know that W divided by Q into Q divided by volume is L cube. Work is equal to here energy, right? Energy, because we know that the amount of work is done to bring a unit positive charge from infinity to that point, that is V definition, potential difference. So if you want to do work, then we need energy. So in place of work, directly I can write energy. Here Q will get cancelled, so energy divided by L cube. Energy dimensional formula ml square t raised to minus 2 divided by L cube. So we will get m capacities L square L cube. L cube means L raised to minus 3. 2 minus 3 will be L raised to minus 1 t raised to minus 2. That indicates this is also having same dimension. That means the fourth option should be right. But you can check here angular momentum. Angular momentum is given by the equation L equal to I omega. Just in the previous problem you have solved the dimensional formula for angular momentum. You can remember it. It is given by ml square t raised to minus 1. You can observe all the four options. A, B and C options are having same dimension, but angular momentum is having different dimension, so that option D is right. Come to the question 74. If I is moment of inertia and omega is angular velocity, then what is the dimensional formula of rotational kinetic energy, which is given by the equation half I omega square? See here, this is dimensional formula for rotational kinetic energy. Anyhow, this is energy. What is the dimensional formula for energy? We know that energy is given by the equation ml square t raised to minus 2. If you know this answer, directly you can tick the option C. Suppose if you don't know the dimensional formula for energy, here already the equation is given. Kinetic energy, rotational kinetic energy equal to half I omega square. Or we can write 1 by 2 into moment of inertia is given by the equation mr square, and in place of omega we can write omega equal to V divided by r square. Substitute the values. Here 1 by 2, this is dimensionless because it is a number. Number is dimensionless, leave it. Remaining is m r square. R square is radius. Radius means it is equal to L square. Remaining is what? V divided by R. V means velocity. Velocity dimension is L t raised to minus 1 divided by radius is L whole raised to 2. So we can write m L square. Here L square t raised to minus 2 divided by L square. Anyhow L square will get cancelled. We will get m L square t raised to minus 2. You can observe the option C here. If you know energy dimension formula, then directly you can write option C. If you don't know, then use this given equation, substitute the dimension, again you will get the same answer. So option C is right. Question number 75. A student, when discussing the properties of a medium except vacuum, you leave about vacuum, he writes velocity of light in vacuum is equal to velocity of light in medium. This formula is, options are dimensionally correct, dimensionally incorrect, numerically incorrect, both A and C. See here, a student when he is going to discuss the properties of a medium, So this equation can be written as, here one equation is given, velocity of light in vacuum is equal to velocity of light in medium. So I am going to rewrite this equation here, or we can write velocity of light in vacuum divided by velocity of light in medium. So this RHS part, when we are going to take on LHS side, it will go to denominator, which is equal to 1. Now you can observe this formula is dimensionally correct as both the sides are dimensionless. You can observe velocity divided by velocity will get cancelled. That may be any medium. So LT raised to minus 1, LT raised to minus 1 will get cancelled. So this is dimensionless. Come to the RHS side, it is a number. Number is also dimensionless. So that indicates this formula is dimensionally correct because on the both side there is dimensionless. But come to the numerical value. Because in the options numerically incorrect or correct, that is also given. So this is dimensionally right. Now we can check numerically. So this equation, velocity of light in vacuum divided by velocity of light in medium. So this is equivalent to refractive index. This is the formula of refractive index. So refractive index is equal to, we can write N2 divided by N1. That means speed of light in vacuum to the speed of light in given medium, N2 divided by N1. So when we calculated refractive index, the answer is always greater than 1. Because you can observe refractive index of air is 1. Refractive index of water 1.33. Refractive index of glass 1.5. You can observe all the options. So these options are greater than 1. Whether numerically it is right? No, because on the RHS side it is not equal to 1. It is almost greater than 1 because it is given in the question except vacuum. If it is vacuum, then we will get 1. But except vacuum, all the values are greater than 1. So this is dimensionally correct but numerically incorrect. So option A and C, these two are right options, or you can go for both A and C. So directly we can write option D is right. Dimensionally correct but not numerically, because the RHS value is always greater than 1 except vacuum or air medium. Question number 76. The dimensional formula of wave number is, yes, we know that wave number, which is denoted by nu bar, is equal to 1 divided by lambda. 1 divided by wavelength, right? The reciprocal of wavelength gives wave number. So 1 by lambda means we can write 1 divided by L. So that is L raised to minus 1. Or we can write m raised to 0, L raised to minus 1, t raised to 0. So this is the dimensional formula for wave number. So the right option is B. Question number 77. The dimensional formula for entropy is, yes, what is entropy? Entropy is the measure of system's thermal energy per unit temperature. First you should know the definition. Entropy, about this term you are going to study in detail in chemistry. Entropy is a measure of system's thermal energy per unit temperature. This is entropy, right? So we can write entropy is equal to system's thermal energy, that is amount of heat energy Q divided by temperature, we can write T. This is not time, this is what? Temperature. So thermal energy per temperature. Thermal energy or energy. Energy means it is given by the dimensional formula m L square T raised to minus 2 divided by temperature is having dimension K. K indicates Kelvin. Remember, we are having 7 fundamental units, right? K is Kelvin. Temperature, it is a fundamental quantity. So now we can write the dimensional formula m L raised to 2 T raised to minus 2 K raised to minus 1. So this is the dimensional formula for entropy. So option C is right. Question number 78. An object is moving through the liquid. The viscous damping force acting on it is proportional to velocity. Then dimensions of constant of proportionality are. See here, the viscous damping force, anyhow viscous force F is proportional to velocity v. According to the problem, it is given viscous damping force acting on it is proportional to velocity. F is proportional to v, or we can write F equal to proportionality constant K into v, because we want to find dimensions of constant of proportionality. So therefore we can write K equal to F divided by v. Now easily you can write the dimension of F and v. F is force is having the dimension m L T raised to minus 2 divided by velocity is L T raised to minus 1. Now you will get the final dimension as L will get cancelled, m T raised to minus 2 plus 1 will be minus 1. M T raised to minus 1, or we can write m L raised to 0 T raised to minus 1. This is the dimension of proportionality constant. So option D is correct. 79th question. The dimension of shearing modulus are. First you have to know what is shearing modulus. Young's modulus, bulk modulus, shearing modulus. So these are the modulus of elasticity you are going to study in the chapter Mechanical Properties of Solid in first year. For second year students, you have already studied. If you know the equation, directly you can write the dimension of shearing modulus. So shearing modulus is given by shearing stress over shearing strain. It is the ratio of shearing stress to the shearing strain that gives a shearing modulus. So generally stress is what? Restoring force per unit area divided by strain is what? Change in configuration to the original configuration, change in length to the original length, change in area to the original area, change in dimension to the original dimension. Generally we can write delta L over L. Yes. Now substitute their dimensions. Force m L T raised to minus 2 divided by area, length into breadth, that is L square. In the denominator you can observe delta L is length divided by L indicates length. Length divided by length, they will get cancelled. So strain is a dimensionless quantity. Leave about the denominator part. Now we will get the final answer m L raised to 1, L raised to minus 2 will be L raised to minus 1, T raised to minus 2. So this is the dimension of shearing modulus. So m L raised to minus 1, T raised to minus 2 means option C is right. Question number 80. The displacement of a body at a particular second n is given by the expression Snth is equal to u plus a by 2 into 2n minus 1. The dimensional formula of Snth in this equation is. Here the equation is Sn is equal to u plus a by 2 into 2n minus 1. See here Sn is what? Displacement of a body at nth second. N is time. Remember, I am going to write Sn is equal to u is velocity, initial velocity. Velocity is having dimension L T raised to minus 1 plus a divided by 2 here. So a is acceleration, or we can write in terms of velocity as you can observe here 2 is, or we can write 1 by 2 outside, remaining is a 2n minus 1. Sn equal to L T raised to minus 1, keep as it is. 1 by 2 is a number dimensionless, leave it. Plus a value acceleration Acceleration means rate of change of velocity. In place of A, I can write V divided by T into 2n minus 1. 2n minus 1, here 2 and 1 they are dimensionless, so we can write n here. What is n? Remember, this is nth second. Nth second means this is time. So I can write Sn equal to L t raised to minus 1 plus V is velocity. Velocity is having dimension L t raised to minus 1 divided by T into N is time. Time means T. Right, now here T will get cancelled. We will get the final answer L t raised to minus 1 plus L t raised to minus 1. You can observe the arithmetic operation here. It is addition. We cannot add the dimensions or we cannot subtract capacities. Sn equal to L t raised to minus 1, L t raised to minus 1. That means the right option is m raised to 0, L raised to 1, t raised to minus 1. So this is the dimension of Snth in the given equation. So the right option is C. Question number 81. The dimensional formula of current density is, yes, current density. It is given by the equation. Current density is current per unit area. Current per unit area, that gives current density. This is the equation. Now utilize this equation here. In place of current, we know that current is denoted by I equal to Q divided by T. So in place of current, I am going to write Q divided by T into area is what? Length into breadth. Length into breadth means we can write L square. Now substitute their values. Q capacities divided by L square T, or you can take these terms to the numerator. M raised to 0, there is no m here, m raised to 0, L raised to minus 2, T raised to minus 1, Q capacities. So this is the dimension for current density. M raised to 0, L raised to minus 2, T raised to minus 1 into Q. So that option A is the dimensional formula for current density. Question number 82. The dimensions of mobility are, yes, first you have to know what is mobility. Mobility means it gives how quickly an electron can move through the conductor. How fast the electrons are moving in the conductor, that is given by mobility. Right? So mobility is generally denoted by symbol mu. Mu equal to drift velocity divided by E, indicates electric field. Vd divided by E. What is Vd here? Drift velocity divided by E indicates electric field. So about these terms you are going to study in the chapter current electricity for first year students. You are going to study these terms in second year, but second year students, you already studied this chapter. So it is easy for you to write the dimension of mobility. Drift velocity, anyhow velocity means its SI unit is meter per second divided by electric field, its SI unit is volt per meter. What is its SI unit? Volt per meter. Or it can be written as meter into meter will be meter square per second per volt. Right? Or in place of V, I can write V indicates voltage potential difference. What is potential difference? Potential difference is amount of work done in bringing a unit positive charge. That means its SI unit will be joule per coulomb. So here instead of V, I can write meter square per second capacities divided by joule per coulomb. Right? Now this equation can also be written as mu equal to meter square per second. You can take coulomb to the numerator divided by joule. Now substitute the dimension meter square per second coulomb. Coulomb means what here? This is the unit of charge, coulomb. We know that I equal to Q by T. Q equal to I into T. I means ampere, current in terms of ampere. T is second, ampere second. So, in place of coulomb, we can write ampere second. So, see here, meter square per second, ampere second divided by joule. Joule can be written as kg meter square per second square. Right? Now, which terms will get cancelled? You can observe. Meter square will get cancelled. Then we will get the answer mu equal to, we can write per kg, s raised to minus 1, s raised to plus 1, these two will get cancelled. So, s raised to plus 2, then A. So, kg means it is the unit of mass, m raised to minus 1. Second is the unit of time, t raised to plus 2, and remaining is A. See here, m raised to minus 1, t raised to 2 into A. So, this is the dimension for mobility. Question number 83. The ratio of dimensions of Planck's constant and that of moment of inertia is the dimensions of. The ratio of, here it is given in the question, Planck's constant divided by moment of inertia. Planck's constant divided by moment of inertia. What is the dimension? First we can find it. Right? So Planck's constant means the amount of energy a photon carries with the frequency of its electromagnetic wave. That gives Planck's constant. Right? What is Planck's constant? The amount of energy a photon carries with the frequency of its electromagnetic wave. Generally, Planck's constant means it is given by the symbol H equal to, its value is 6.62 into 10 raised to minus 34 joule second. And it is having the equation E equal to HF, or H equal to E divided by F. Substitute the values of E and F. Energy divided by frequency. Energy is m L square t raised to minus 2 divided by frequency is what? 1 by t. Or we can write H equal to m L square t raised to minus 2 divided by 1 by t means t raised to minus 1. Or we can write m L square t raised to minus 2 plus 1 will be t raised to minus 1. This is the dimension for Planck's constant. For moment of inertia, we know that moment of inertia is denoted by the symbol I equal to mr square. It is the product of mass and square of position vector. I equal to mr square. Mass, that is m, r square, radius, that is L square. So, we can write m L square t raised to 0. Now, you can divide these two values. See here, I can divide m L square t raised to minus 1 is dimensional formula for Planck's constant divided by m L square t raised to 0. This is dimensional formula for moment of inertia. What we can get the final answer? M will get cancelled, L will get cancelled. Remaining is what? T raised to minus 1, or we can write 1 by T. So 1 by T is equal to what? Frequency. Frequency is equal to 1 by T. So the suitable dimension is for frequency. Option D is right. Question number 84. Which of the following have the same dimensions? Options are given: thermal capacity, universal gas constant, Boltzmann constant, all of the above. Yes, we can observe one by one. Option A is given thermal capacity. Yes, first we have to know what is thermal capacity. Thermal capacity means amount of heat energy. Amount of heat energy per unit temperature. Amount of energy over temperature. Energy is having the dimension formula L m L square m T raised to minus 2 divided by temperature is having dimension K, that is Kelvin. So we can write L square m T raised to minus 2 K raised to minus 1. This is the dimensional formula for thermal capacity. Come to the second option, it is given universal gas constant. What is that? Universal gas constant. We know the equation PV equal to RT, or R equal to, we can write PV divided by T. Here PV indicates again energy, pressure, volume, energy, work done. Right? You have studied isothermal process and adiabatic process, and you already studied about PV diagram. This is energy here. Energy over temperature. So energy means L square m T raised to minus 2 divided by temperature is Kelvin. Again we can get the same answer, that is L square m T raised to minus 2 K raised to minus 1. So this is also having same dimension. Come to the option C, that is Boltzmann's constant. Yes, it is generally denoted by the symbol K. K equal to Boltzmann constant means average kinetic energy of particle in a gas over temperature of the gas. Average kinetic energy of particles in a gas divided by temperature of gas. This is what Boltzmann's constant. K equal to kinetic energy. Anyhow, energy means again the equation L square m T raised to minus 2 divided by temperature is what? Kelvin. So we will get again L square m T raised to minus 2 K raised to minus 1. So here thermal capacity, universal gas constant and Boltzmann constant, all these three quantities are having same dimension. So the right option is D. All of the above having same dimension. Question number 85. The dimensions of electromotive force in terms of current A are. Electromotive force. Here electromotive force is equal to potential difference. Both are same here. Electromotive force means potential difference, or we can call it as voltage. So we have to express in terms of current, then their dimensions will be. Yes, potential difference is generally denoted by V. V equal to, we know the equation W by Q. So W is work done. Work is given by the equation m L square T raised to minus 2 divided by. In place of Q, we can write, see here, we have the equation I equal to Q by T, Q equal to I into T. So we can write in place of Q as I into T. I indicates the current. So m L square T raised to minus 2 divided by current is having dimension A into T. So we will get the final answer as m L square T raised to minus 2 minus 1 will be T raised to minus 3 A raised to minus 1. So this is the dimensional formula for electromotive force in terms of current A. So m L square T raised to minus 3 A raised to minus 1. Option D is right answer. Question number 86. The dimensions of Veina's constant are. See here, Veina's constant. It is denoted by the symbol B. B equal to lambda m into T. This is the equation we can use here. So B equal to lambda indicates wavelength. Wavelength is what? L. And T indicates temperature. Temperature means we can express in terms of Kelvin. So its dimension will be m raised to 0, L raised to 1, T raised to 0, K raised to 1. This is the dimension formula for Veina's constant. So the right option is option B. M raised to 0, L raised to 1, T raised to 0, K raised to 1. Question number 87. Let Q denote charge on the plate of the capacitor of capacitance C. The dimensional formula for q square divided by c is, see here, q square divided by 2c. This is energy of capacitor. What it is? Energy of capacitor. So we can write the dimensional formula for energy directly because 2 is a dimensionless. See here, therefore, energy dimensional formula is, see here in the given problem, the equation is q square by c. This is energy of the capacitor. So energy of capacitor means we can directly write energy dimensional formula. So that is m L square t raised to minus 2. M L square t raised to minus 2 is dimensional formula for energy. That is q square divided by 2c. So that option A is right. Sorry, option C is right. Question number 88. The dimensions of Planck's constant are as same as. Yes, we already derived dimension formula for Planck's constant. Yes, I can directly write that is H equal to m L square t raised to minus 1. This is dimensional formula for Planck's constant. Now you can observe all the 4 options which is having same dimensional formula that we have to check here. Option A is energy. Energy is having dimension m L square t raised to minus 2. So this is different from Planck's constant. Leave it. Come to option B. Power. Power is rate of doing work, that is W divided by T. W means it is equal to energy. Energy over time. Energy means it is having the dimension m L square t raised to minus 2 divided by T. So we will get m L square t raised to minus 3. So this is also different from Planck's constant. Leave it. Come to option C. Momentum. Linear momentum is given by the equation P equal to m into V. So that is mass into velocity is having L t raised to minus 1 dimensional formula. M L t raised to minus 1. It is again different from Planck's constant. So option D should be right here. Angular momentum. Angular momentum is denoted by L. L equal to I omega. So we already know its dimensional formula, that is m L square t raised to minus 1. So here Planck's constant dimension and angular momentum dimensions are same. So option D is correct. Question number 89. If L denotes inductance of an inductor through which a current I is flowing, the dimension of Li square R. See here, you are going to study in the chapter electromagnetic induction about energy stored in an inductor. Energy stored in an inductor is given by the equation E equal to 1 by 2 Li square. The given equation is also Li square here, or we can write this equation as Li square is equal to 2E. 2 is dimensionless, leave it. Li square equal to E. E means what here? Work. Work is what? Force into displacement. So now you can write down their dimensions. Li square is equal to, force is m L t raised to minus 2. Displacement is L. So we will get Li square is equal to m L square t raised to minus 2. So this is the dimension of Li square. So m L square t raised to minus 2. That means option A is correct. Question number 90. The dimensional formula for velocity gradient is, velocity gradient is velocity per unit distance. What is velocity gradient? You have studied about temperature gradient in thermal properties. Likewise, velocity gradient. This is velocity per unit distance. Velocity per unit distance means we can write velocity divided by distance. Velocity is having dimension L t raised to minus 1. Distance is L. So we can write t raised to minus 1. So m raised to 0, L raised to 0, t raised to minus 1. So this is the dimension formula for velocity gradient. So option A is correct. Question number 91. The division of energy by time is x. The dimensional formula of x is as same as that of. See here it is very simple question. Here it is given division of energy by time is equal to x. So we can write energy divided by time, that gives power. We know that rate of doing work. So directly I can write it is equal to power. That means m L square t raised to minus 3. See here, we know that power equal to W by T, rate of doing work. So work done is equal to what? Energy over time. Energy over time gives power. So power is having dimension m L square t raised to minus 3. So power is equal to x. Option B is right. Question number 92. ml t raised to minus 1 plus ml t raised to minus 1 is equal to. Here you can observe arithmetic operation is addition and these two quantities are having same dimension. Observe these two quantities m, l, t raised to minus 1. So now you can remember principle of homogeneity. Principle of homogeneity of dimension. Addition, subtraction or equality between two quantities of same dimensions are possible. It is possible for same dimension. And remember, the result also have the same dimension. There is no change in the result. So again we will get m l t raised to minus 1. Option B is correct. Remember this condition for addition, subtraction or equality. Addition, subtraction of or equality between two quantities of same dimensions are possible. Remember, if they are having different dimension, then you have to consider only multiplication or division. But here they are having same dimension. It is possible and the result also have the same dimension. Result also have the same dimension. So option B is correct. Question number 93. If force F, acceleration A, time T are the fundamental units, then dimensions of work are. See here, work is given by the equation force into displacement. Force is having the dimension here, it is given as F, capacities. Displacement, instead of displacement, see here, velocity equal to S by T. S equal to V into T. So in place of S, I can write V into T. Then F capacities in place of velocity. See here, what is acceleration? Rate of change of velocity. A equal to V by T. V equal to A into T. So in place of V, I can write A into T into T capacities. So we will get F A T square. So this is the dimension of work. F A T square means option C is right. Question number 94. Given that K equal to energy, V equal to velocity, T equal to time. If they are chosen as the fundamental units, then what is the dimensional formula for surface tension? Surface tension T is equal to force per unit length. This is the formula. T equal to F divided by L. Just I am going to modify this equation. Observe here. T equal to F divided by L keep as it is into. I am going to multiply L and divide L. If L and L get cancelled, we will get the same answer. Into T square divided by T square I am using here. T square, L and L, if they get cancelled, we will get again the same answer. Right? Then we know that work is given by the equation force into displacement. Work equal to what? Force into displacement. Or work is equal to what here? Work done is equal to energy. Energy equal to force into displacement. Displacement means L. So now I can write energy here in the problem. It is equal to K. K equal to energy F into L. Right. Now let us consider this equation. We can use it later. Then similarly, velocity. What is velocity? Rate of change of displacement S divided by T. I am going to square this equation. Squaring on both sides. What you will get? Squaring. V square equal to S square divided by T square. S indicates the displacement. So we can write L square over T square. We want T square equal to L square divided by V square, or T square divided by L square equal to 1 by V square, or T square by L square equal to V raised to minus 2. This equation again I am going to use later. Got it? K equal to F into L. T square by L square equal to V raised to minus 2. Now come to the surface tension equation. So what we wrote here? Surface tension T equal to, we wrote F divided by L into L divided by L into T square divided by T square. I am going to modify it. T equal to F into L into T square divided by L square into 1 by T square. Observe the above equation, both are same here. F into L into T square divided by L into L will be L square into remaining is 1 by T square. So now substitute the value. What is F into L? That is K into T square by L square is V raised to minus 2. 1 by T square, that is T raised to minus 2. So we will get surface tension T equal to K V raised to minus 2 T raised to minus 2. K V raised to minus 2 T raised to minus 2. That means option A is the right answer. Question number 95. Which of the following units denotes the dimension ml square by q square, where q denotes the electric charge? See here, m, given equation I am going to write here, m L square over q square. Here we know that q equal to I into T. I equal to q by T, q equal to I into T. This is the given equation. In that I am going to take one term outside, q. Q means I into T. Easily we can write its dimensional. Q equal to current is ampere. T, time indicates T. A into T. This is the dimension for charge. Then equation is what here? M L square divided by, in place of q square we can write A square T square. Right? Then this equation can also be written as m L square A raised to minus 2 T raised to minus 2. So this is what the dimension of the given equation. Here the question is, which of the following unit denotes the dimensions? Which unit is suitable for this dimension? That we have to check here. Right? So first one by one we can observe the options. Remember this equation. Now the first option is Weber per meter square. See here, first we can go to Weber. So easily we can find Weber per meter square. So here I am going to write option D here. Option D is about Weber, or we can write WB. This is the unit of magnetic flux. This is what? Unit of magnetic flux. You are going to study in the chapter electromagnetic induction as well as in alternating current. Right? So we know the equation here. E equal to d pi divided by dt. E is what? EMF. EMF means it is equal to potential difference. Potential difference means V equal to W by Q. We can utilize here. D pi by dt. Pi is what here? Magnetic flux. This pi is magnetic flux. I am going to rewrite this equation as W divided by Q is equal to d pi divided by dt. W divided by Q. W means work. Work is having the dimension m L square t raised to minus 2 divided by Q is having the dimension a t. Or we can write this is equal to m L square a raised to minus 1 t raised to minus 3. So this is the dimension for magnetic flux. Right? Or we can write yes, this is what? Dimension for change in magnetic flux with respect to time. So therefore, here I am going to write d pi is equal to m L square a raised to minus 1 t raised to minus 3 into dt. dt means time here. So pi equal to m L square a raised to minus 1 t raised to minus 3 into t, or d pi equal to m L square a raised to minus 1 t raised to minus 3 plus 1 will be t raised to minus 2. This is the dimension for magnetic flux. Yes, observe here m L square a raised to minus 2 t raised to minus 2. This is our equation, dimensional formula. Compare these two values, whether they are correct, both are different or whether they are same. Observe this one and this one. They are different. Different means Weber is not the right option. Then come to option B, Henry, or you can go to Weber per meter square. Option, I am going to take option A here, Weber per meter square. Easily you can find here Weber means its dimension is m L square a raised to minus 1 t raised to minus 2 divided by meter square is L square. L square will get cancelled. We can write m a raised to minus 1 t raised to minus 2. This is for option A. Whether it is same here? No. Again Weber per meter square is also wrong. Come to the option B, Henry. Henry is, it is the unit of coefficient of inductance. Coefficient of inductance. See here, I am going to solve option C in this place. Observe carefully here. Option B, that is Henry. Henry is unit of coefficient of inductance. We have the equation E equal to L into di divided by dt. This equation I am going to use here. L equal to, this equation can be written as E divided by di into dt. E into dt divided by di is equal to, see here E is having the dimension. We already got its dimension here, you can observe. E equal to d pi by dt, right? E means what here? EMF. So here E equal to d pi by dt, this value we can substitute here. M L square a raised to minus 1 t raised to minus 3 into time t divided by dt is again, here this is not dt, this is di, means this is ampere. Now we can write its final equation as, see, I am going to write this part here, observe carefully. L equal to m L square, a raised to minus 1, a raised to minus 1 means a raised to minus 2, t raised to minus 3 plus 1, t raised to minus 2. This is the dimensional formula for the unit Henry. Observe these two here, m L square, a raised to minus 2, t raised to minus 2. Yes, both are same. Option B is correct. Or you can observe equation 1. Compare with equation 1. Both are same here. So option B is right. Suppose if you are using option C, Henry per meter square. Henry per meter square means divided by L square. L square will get cancelled. So this is not the proper answer. So which is the right option? Henry is the right answer. Option B. Question number 96. If V equal to A by T plus bt cube, where V is velocity, T is time, the dimensional formula of A and B are. See here you can use a dimensional analysis. Remember, I am going to write V equal to A divided by T, V equal to B T cube. Separately I am going to write these terms. V equal to A by T means A equal to V into T. Here also B equal to V divided by T cube. Substitute the dimension. Velocity L t raised to minus 1 into time t. So we will get the answer L. T and T will get cancelled. Here V is velocity L t raised to minus 1 divided by T cube. So we will get the answer L t raised to minus 1 minus 3 will be minus 4. So what are the dimensions? A is having the dimension L and B is having the dimension L t raised to minus 4. L and L t raised to minus 4 means option B is correct. Question number 97. Dimensional formula of Stephen's constant is. See here, Stephen's constant, it is denoted by the symbol sigma and it is given by the equation energy over area into time into temperature raised to 4. Remember this equation. Energy divided by the product of area into time into 4th power of temperature. Now easily you can substitute the values. Energy dimension is m L square t raised to minus 2 divided by area length into breadth, that is L square. Time is T. Temperature is Kelvin K raised to 4. So we will get its dimension as m L square will get cancelled. T raised to minus 3 K raised to minus 4. This is the dimensional formula for Stephen's constant. So option A is correct. 98th question. Dimension of resistance in an electrical circuit in terms of dimensions of mass m, length L, time t and current I would be. See here we have to find dimension of resistance. We know that Ohm's law V equal to IR. I equal to V divided by R. But we want R value. R equal to V divided by I. So potential difference is having the dimension we already studied m L square t raised to minus 3 a raised to minus 1 divided by a. So we will get m L square t raised to minus 3. Here in place of a it is given in the problem as I raised to minus 1, I raised to minus 1. So we can write m L square t raised to minus 3, I raised to minus 2. This is the dimension for resistance. So the right option is option C. M L square t raised to minus 3, I raised to minus 2. Question number 99. Dimensions of capacitance are. Yes, directly we have the equation C equal to Q divided by V. Or we can write Q divided by V is potential work done in bringing a unit positive charge. We can write Q square divided by W. Q is equal to I into T square divided by W. So we can write A square T square divided by work is given by the dimension ml square t raised to minus 2. So therefore we can write its dimension as m raised to minus 1, l raised to minus 2, t raised to minus 2 plus 2 will be plus 4, a raised to 2. So this is the dimension for capacitance of a capacitor. So the right option is A. Question number 100. The dimensional formula for magnetic flux is. We know that magnetic flux we already derived, or you can remember this equation E equal to d pi by dt. D pi is equal to E into dt. E indicates this is the dimension for voltage into dimension of time. Dimension of voltage into dimension of time, substitute their value. Voltage means m l square t raised to minus 3 a raised to minus 1 into dimension of time is t. So we will get the final answer m l square t raised to minus 2 a raised to minus 1. So this is the dimensional formula for magnetic flux. So the right option is option A, m l square t raised to minus 2 a raised to minus 1. Question number 101. Which of the following pairs has the same dimension? Two pairs are given here: angular momentum, Planck's constant, dipole moment, electric field. So which pair is having same dimension, that we have to calculate. See here, the first pair is angular momentum is having the dimension, I am going to write it directly, m l square t raised to minus 1. The second term is Planck's constant. Planck's constant is having the dimension m l square t raised to minus 1. Both are same here. Both are having same dimension. This is option A. Come to option B. Dipole moment. Dipole moment means it is denoted by P. P equal to Q into D. So unit positive charge into respective distance. So we can write in place of Q as I into T, and displacement means L. So we can write A T L, or L raised to 1, M raised to 0, T raised to 1, A raised to 1. Right? Now, second term is electric field. Electric field is given by the equation E equal to F divided by Q. So F is ml t raised to minus 2. Charge Q is A into T. So we will get m l t raised to minus 3 A raised to minus 1. So here first pair is having same dimension. So option A is right. Question number 102. If time t, acceleration a, force F are regarded as base unit, then dimensional formula for work is. Yes, this question is repeated here. We already solved this question. That is, you can observe question number 93. The same question here repeated. Come to the question number 103. The dimensional formula for permeability mu is given by. Permeability. See here. Permeability is denoted by mu. We have the equation. I am going to write B A 2 pi divided by I. So this equation is called Biot-Savart's law. Magnetism, moving charges and magnetism, there you studied about Biot-Savart's law. I am going to utilize this equation to find its dimensional formula. Remember here B indicates magnetic field, A indicates distance of Observation points. A indicates distance of observation points from a conductor and I is electric current. Now I am going to write in place of B, dimension of B, magnetic field dimension of B is F divided by Q into V. First we can write its dimension. F is force ml t raised to minus 2 divided by Q means here it is A. F indicates force, Q indicates charge, V indicates velocity here, LT raised to minus 1. So this is the dimension of B. Now we can substitute in mu. Mu equal to B means what here? M L T raised to minus 2 divided by A T into L T raised to minus 1. B value into area, that is L square. Right? Divided by I means current. In place of current we can write the value A into T. We substitute all the values in the Biot-Savart equation. So we will get the final answer m raised to 1, L raised to 1, T raised to minus 2, A raised to minus 2. So this is the dimensional formula for permeability. M raised to 1, L raised to 1, T raised to minus 2, A raised to minus 2. That means option A is the right answer. Question number 104. The volume V of a liquid crossing through a tube is related to the area of cross section A. The velocity V and time t as V is proportional to A raised to A, V raised to B, T raised to C. Which of the following is correct? Yes, observe here the given equation is V is proportional to A raised to A, V raised to B, T raised to C. V indicates volume, volume is L cube, proportional to A indicates area, L square, raised to A. Then V indicates velocity, L T raised to minus 1, raised to B, and time is T raised to C. Or we can write L cube is proportional to L raised to 2A, L raised to B, T raised to minus B, T raised to C. Or we can write L raised to 3 is proportional to L raised to 2A plus B, T raised to minus B plus C. So therefore, we can write 2A plus B. Compare LHS and RHS values here. 2A plus B equal to what? 3. And here minus B plus C equal to 0 because there is no T term on the LHS side. So B equal to C here. Right? Come to this term 2A plus B equal to 3. Or we can write 2A equal to 3 minus B, A equal to 3 minus B divided by 2. This is A value. Now compare these terms. B is equal to C. Yes, right. Whether A is equal to B? No. A is not equal to B, but B is equal to C. A equal to B, A is not equal to B, B equal to C. Means option C is correct. Question number 105. The time of oscillation T of a small drop of liquid depends on radius R, density ρ, surface tension S. The relation between them is given by. Here, the time of oscillation T for a small drop of liquid, it is given here. You can utilize all the 4 options. Then you will get the answer. First option is T is proportional to root of S divided by rho R cube. Here, S indicates surface tension. It is having dimension m T raised to minus 2 divided by rho indicates density. It is having dimension m L raised to minus 3 into R indicates length L cube. Or we can write m and m will get cancelled. L raised to minus 3, L raised to plus 3 will get cancelled. Root of T raised to minus 2. We will get the answer. Then option B. T is proportional to root of rho r cube divided by S. Again substitute the values. Density is m L raised to minus 3 into L raised to 3 divided by S is m T raised to minus 2. Now we will get the answer. M and M will get cancelled. L raised to minus 3 plus 3 will get cancelled. Root of 1 by T raised to minus 2. That means T raised to plus 2 T square is equal to T. So we got the answer. Option B is right. Not necessary to find option C and D. Again you can go and substitute the values. We will get different answers. But here option B is the right answer. Option B and D both are same here. There is no difference in them. B and D both are correct answers. Question number 106. The velocity of water waves V may depends on their wavelength lambda, density of water rho, acceleration due to gravity g. The method of dimension gives relation between these quantities is. Yes, see here I am going to write velocity of water V. It is depending on, means we can write proportionality. It is depending on wavelength lambda. Density means rho. Acceleration due to gravity means g. Their dimension means we can write lambda raised to a, rho raised to b, g raised to c. Right? Or we can write v is velocity having dimension L t raised to minus 1 is equal to, or it is proportional to, lambda is wavelength. Wavelength means it is equal to L raised to a. Density is having dimension m L raised to minus 3 raised to b. Acceleration due to gravity L t raised to minus 2 raised to c. Now easily you can find the relation between the given quantities. L t raised to minus 1. Here m is not given. You can write m raised to 0. Is equal to, or it is proportional to, L raised to a. Here m raised to b. L raised to minus 3b, L raised to c, t raised to minus 2c. M raised to 0, L, t raised to minus 1, keep as it is proportional to, L terms you can observe, L raised to a minus 3b plus c, M raised to b, t raised to minus 2c. Right? Now you can compare the terms from LHS and RHS side. A minus 3b plus c is equal to what? 1. B equal to 0. Minus 2c is equal to minus 1. Therefore, c equal to 1 by 2. Right? We got c value and b value. Substitute in a. We will get a minus 3 into b is 0 plus 1 by 2. Is equal to 1. A minus 3 into 0 will be 0 is equal to 1 minus 1 by 2. That gives 1 by 2. Therefore, A equal to how much? 1 by 2. Substitute these values in equation number 1. I am going to write here. V is proportional to lambda raised to A. A is how much? 1 by 2. Rho raised to B. B is what? 0. Rho raised to 0. G raised to C is what? 1 by 2. So, V is proportional to lambda raised to 1 by 2, G raised to 1 by 2 because rho raised to 0 will be 1. Leave it. V is proportional to root of lambda into G. Or V square is proportional to lambda G. Now you can observe the options which is the right answer. V square is proportional to G lambda or lambda G. So option B is right. Question number 107. The speed of sound in a gas is given by V equal to root of, this is what? Gamma RT divided by M. R is universal gas constant, T is temperature, M is molar mass of gas. Then the dimensional formula for gamma is, yes, what is gamma? See here, gamma is the ratio of specific heat capacities. The ratio of specific heat capacity, you can remember this equation, Cp by Cv equal to gamma. Cp by Cv equal to gamma, this is dimensionless. Dimensionless means the value will be m raised to 0, l raised to 0, t raised to 0. So option A is correct. Question number 108. Which of the following do not have the same dimensional formula as velocity? Given that mu naught is permeability of free space, epsilon naught is permittivity of free space, and nu, this is not V, this is nu. Nu is frequency, lambda is wavelength, P is pressure, rho indicates density, omega indicates angular frequency, K indicates wave number. Which of the following do not have the same dimension formula as velocity? Remember, velocity dimension formula V equal to L t raised to minus 1. So these following options do not have this dimensional formula, right? Come to the first option, 1 divided by root of mu naught into epsilon naught. Yes, mu naught into epsilon naught, absolute permeability, absolute permittivity. So here directly I am going to write their values, mu naught and epsilon naught. Mu naught is m, l, t raised to minus 2, a raised to minus 2. Similarly, into epsilon naught is m raised to minus 1, l raised to minus 3, t raised to 4, a raised to 2. This is the dimensional formula for permeability and permittivity. Solve this value. 1 divided by, here m raised to plus 1, m raised to minus 1 will get cancelled. L raised to 1, L raised to minus 3. 1 minus 3 means how much? Root of L raised to minus 2. Then t raised to minus 2 plus 4. Minus 2 plus 4 will be t raised to 2. Then a raised to minus 2, a raised to plus 2. They will get cancelled. So what we got now? L raised to minus 2, t raised to 2. Or we can write it as 1 divided by L raised to minus 2 into 1 by 2 will be minus 1. T raised to 2 into 1 by 2 will be t raised to 1. So we will get L t raised to minus 1, means these are having same dimension but we want different dimension quantity. Come to the option B. V lambda. V lambda is equal to, I can write here, it is not V here, this is nu. Nu means frequency, here it is given in the problem. Frequency is 1 by t into lambda indicates wavelength is L. So L divided by t, that gives L t raised to minus 1. This is also having same dimension as velocity. Come to option C, root of pressure divided by density. Yes, pressure divided by density. Pressure dimension is m L raised to minus 1 t raised to minus 2 divided by m L raised to minus 3. This is for density and for pressure. Now we will get the answer as root of, here m and m will get cancelled. L raised to minus 1 plus 3 will be 2 L square into t raised to minus 2 L square t raised to minus 2, or we can write here L raised to 1 t raised to minus 1. So this is also having same dimension. Of course option D should be right, but you can check here. This is what? Omega into K. What is omega? Angular frequency. Angular frequency is given by the equation, that is 1 by t, f equal to 1 by t into K is wave number. Wave number is the reciprocal of wavelength, that is 1 by L. So we can write, this is frequency 1 by t here. 1 by t, 1 by L means L raised to minus 1, t raised to minus 1. So this is a different dimensional formula from velocity. So option D is the right answer. Question number 109. In the equation P equal to RT divided by V minus B into E raised to AV divided by RT, where V is volume, P is pressure, R is universal gas constant and T is temperature. The dimensional formula of A is as same as. Yes, I am going to concentrate only this part because I want only A value. See here, E raised to AV by RT. The equation is AV divided by RT. This is as same as PV divided by RT is equal to N, where N is a number. This is dimensionless. If N is dimensionless, then A is equal to what? P. P indicates pressure. So option B is the right answer. Question number 110. The Richardson equation is given by I equal to A T square E raised to minus B over K into T. The dimensional formula for AB square is as same as. See, I am going to write the equation. I equal to A T square E raised to minus B over KT. Separately, I am going to write these value. A is equal to I divided by T square. E raised to minus B divided by KT. So here dimensions of B is equal to what? K into T. Because power of exponential is dimensionless. Right? So we can write AB square is equal to, A value means I by T square into B square means KT whole square. So T square will get cancelled. We will get IK square. IK square means option C is right answer.